Okay, so we are going to work on 2 more sections to finish off chapter 8. So today and tomorrow will be the next 2, and it'll be our last 2. And then we'll go ahead and take 1 more quiz before spring break, and then you'll finally get a chance to go on break. All right, so 2 more weeks. I know, we're almost done. All right, so today is going to be about rational functions. Now, we spent 3 sections talking about these expressions. All right, that's what the rewind was helping you remember. What did you do in the rewind?
Excluded values?
Yes, but before that. So even though we did factoring, what is the actual instructions were to simplify, which was just factoring. Okay? So these are rational expressions. Why are they rational expressions? So rational, what math word is in the word rational? Ratio. So they are fractions. And what's in the denominator? Variables, the x. Okay, so if we ever have variables in the denominator and it's fractions, then it's going to be a rational expression. So now we're going to talk about the function. So this is the parent function, your basic function, 1 over x. So nothing in the numerator except for the number 1 and your variable in the denominator. So what is an excluded value that x cannot be? 0, right? 1 divided by 0 is not possible, so x cannot be equal to 0. So this is what the graph looks like. There's actually 2 pieces to it, these 2 curves. All right, and this is called a hyperbola, all right, which we'll do a lot more work on in chapter 10, but you're getting an introduction to it here. Do you guys see the dotted lines? Do you remember what those are from early on in this class?
Shade?
No.
Shading?
No. What are it? No. Oh, those are the axes.
Whatever, flex off.
It actually cannot be equal to those. That's why they're dotted lines there. We already forgot? Asymptotes. All right, which we've already talked about a little bit. All right, we had the axis of symmetry, which was kind of like an asymptote. But again, asymptotes are things that it cannot cross. And notice the curves are not touching or crossing those asymptotes. All right, so we can't have any values on those lines. All right, now we're going to use this the whole class period. All right, so the letter A, for the beginning part of class, it's going to be just the number 1. All right, to keep it straightforward. But that might change to be a negative or a larger number, like 2 or 3. All right, so you'll see what happens when that changes. This down here, all right, when we have a variable down here, we know that we cannot have 0 in the denominator. So we're talking about what are our excluded values. And the reason I had you do that in the rewind is because the excluded value is actually going to be our vertical asymptote. All right, so we're going to draw a vertical dotted line at that number because we can't touch that number. All right, this number out here is also going to be an asymptote, but it's going to be our horizontal one. All right, so notice we've done this before with H and K. Talks about translating vertically and horizontally. Remember covertical. All right, so we're talking about how to use this information to help plot. So let's try an example. All right, so we have 1 over x minus 3 plus 2. The first thing you want to do is you want to write your asymptotes. So I'm going to write VA for vertical asymptote. Vertical asymptote. This is always going to be x equals a number. And I always look at my denominator. What is the excluded value for this function?
3.
Positive 3, right? Because 3 minus 3 is 0, and I can't have that. All right? So that is my vertical asymptote. So when I go over to x equals 3, what am I going to do? I'm going to put a vertical dotted line. All right, so go on your x-axis to 1, 2, 3. I'm going to put a dotted line right there. All right, that's my vertical asymptote. Now, guys, the horizontal asymptote is a little bit trickier, so listen about why we have another asymptote. All right, this is going to be y equals a number. Now, since my numerator is the number 1, can I ever get this component here, 1 over x minus 3, to be 0? No. Why? How would I get a fraction to become 0? How do I get a fraction to become 0? Where do I need the 0? In the numerator. Will my numerator ever be 0? No, it's always 1. So if this is never 0, then what y value am I never going to have? No, I'm never going to have 0 plus 2, because I'll never have 0 here. So I'll never have what number? I'll never have 2. So that is the other asymptote. Y equals 2. So whatever number is out there, that's another asymptote. All right? So I go to the y-axis, and I go to 2, and I put a horizontal dotted line. So those are kind of going to be our guidelines for how to draw these curves. Remember, there's going to be 2 components, 2 curves. Now, are these a part of the graph?
Yes.
Are these a part of the graph? How do I know that they're not a part of the graph? Because they're dotted. All right? They're going to help us graph it, but it's not actually a part of the function when you graph it. Okay, so I know it's kind of confusing. Yes, you need to do this, but it's not actually a part of the graph. All right, the last thing I do is I put an X and Y table to help plot points. A little T-chart. All right? Now your goal is to get the denominator to become 1 or -1. I'll repeat it. Your goal is to find out what values for X make the denominator become 1 or -1. So what value for X is going to make that work? 4. 4 minus 3 is, what is 1 divided by 1? Plus 2, 3. So I'm going to plot the point 4, 3. Everybody good with that? So I want to get the denominator to become 1, which I did. Now what number would make the denominator become -1? 2. 2 minus 3, -1. 1 divided by -1. Plus 2, 1. So I'm going to go over 2 and plot 2, 1. That's all you need with this one to plot these curves. All right, because what do I have that's going to help me draw the curves? I have the dots, but I also have what on there? The dotted lines, what are those called? The asymptotes. The asymptotes. And the asymptotes are going to help me draw this. So you ready? Here we go. So remember, it gets closer and closer and closer, but it never touches the asymptote.
You just draw it like wherever you want.
No, I did not draw wherever I want. I get closer and closer to the dotted lines without touching them.
Look, in the example, it doesn't show that.
Yes, it does in the example. They're getting closer and closer to the asymptotes. The reason it's such a bigger space is because they have everyone as half. Not in my case. All right. Now, we're not actually finished. If you look at the instructions, it says to do the asymptotes, which we did. We graphed it. Awesome. Now what's left? Domain and range. A lot of students have a lot of trouble with this. All right. So do you guys remember how to do the domain and the range? Domain and range just tells me what are my possible values that work for this function. Domain, the x values, the range, the y values. Now, all of the values for x and y are good except for 2. What are the only 2 values that I can't have? 3 and 2. And now, which one do I care about for the domain and which one for the range? Domain, the x cannot be 3, and my range, y cannot be 2. And that's it. So you're going to write all real numbers, all real numbers, right? Remember our symbol for all real numbers, capital R, except x cannot be equal to 3. That's an asymptote. Okay? And then for the range, all real numbers, except y cannot be equal to 2. So your asymptotes are going to be your excluded values. Are there any questions about the process? No. Okay, now before I let you guys stay seated to do the practice problems, because it is graphing, all right, let's just talk about those problems. Now, Lupe, you already noticed that there are tons of blank coordinate grids here. I gave you a few extra in case you mess up, all right, so you don't have to use all of them, so don't worry. All right, so let's look at these 4 real quick. 1 and 2 should be just like the example. All right, do you see what's in the numerator? 1, so that's great. What do you notice about 3 and 4?
-1 and 2.
So something's going to happen here that's going to be interesting. We'll talk about that before you leave. And then notice here, it's not even the number 1. So when I'm doing my what values make my denominator 1 or -1, I'm actually going to do 2 more. What values make my denominator also 2 or -2? So not just 1 or -1, but also 2 or -2. All right, so you should be plotting how many points on this one? 4. And I made it nice to remember. It is number 4. So when you get to number 4, you need 4 points. All right, 1, 2, and 3, you just do the 2 points that we've done. Questions? So you're going to stay seated. You're going to stay seated, all right, which is not moving. I'm going to walk around with the answer key. So whenever you're ready, as I walk around, don't be like, ooh, ooh, ooh. Just when I get near you, just be like, Mr. Frantrick, and then I can show you the answers. Okay, everybody good?
Yes.
All right, awesome. Go.